Okay, C3H5X. I'm sorry, C3H2X, where X is a halogen. Alright, that's a toughie, because I don't see a 1-to-1 ratio here. But you know what? That's going to be weird anyways. Look at this, C3H2. What could be C3H2? I don't think I can think of anything that's C3H2. It just about has to be C6H4. But look at this. Let's C6H4. Let's take a glance down at the... Aha! It's between 6.5 and 8, and it's a single peak. So that means all the hydrogens are the same, and it also means it's aromatic. Okay? So we automatically know we're going to be going to C6. H4X2, and it looks like both the X's are the same. Alright, and that would account for this weird pattern here. So this could be a 1 to 3, but with 2 chlorines it's going to be a more complicated pattern, right? Okay, which we did the Punnett square in class with bromine, but let's look at that. Okay, C3, let's suppose this is C6H4, and I'm going to say chlorine 2. 6 times 12, let's do it here. 6 times 12 plus 4 times 1 plus 35 times 2 is equal to 72 plus 4 plus 70, which is equal to 146, which is what we have here. Okay? Super, 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 super. Okay? So maybe I'll post another video explaining why this would be a weird pattern. If you have 2 chlorines, if it's a 1 to 3 pattern, that's real easy to see. But if it's got 2, it's going to be a more weird pattern, right? Because 75% of them are chlorine 35, and it's not a 50-50 mixture like we did with the Punnett square and genes for blue eyes and brown eyes. In case you remember that from biology class. All right, so 146. So this is definitely it. It's C2, or rather C6H4Cl2. Okay? Use that. And that's if it's chlorine 35. Alright? Now that we have that, oh goodness, it's a quick jump off now. If it's a benzene ring and they're all the same, there's only one way to do that. Right? So let's go ahead and... Do you agree that all these hydrogens are exactly the same? Okay, so I'm going to call that A. Type, number, N plus 1, and shift. Okay, type is A. The number, there are 4 of them. They have 0 neighbors, 0 non-equivalent neighbors, right? N plus 1, so it's going to be a singlet, and it's going to be between 6.5 and 8, which we clearly see that it is. Okay, so this is A, and that explains how that goes. Okay, that explains how we know that that is A. Alright. Now, we go here and we see that we've got a benzene ring, so we're expecting peaks at 15 and 16, and they could be these two shifted down a little bit. What's that? 13? Could be 14 and 15, possibly. Okay. That's at 16. Now it could be that one too. Alright. And this is an sp2 hydrogen. Okay. And so that's that structure for spectroscopy practice number 4.